Let's talk about how we settle humanity on the moon. We know that people have walked on the moon and even spent a little bit of time up there doing stuff like driving a dune buggy and playing golf, but that's about it. And we're going to go back to the moon at some point in this decade, hopefully, to do it all again with the Artemis program. As far as we can tell, there still is no real point to the Artemis 3 moon landing other than for America to prove that it can still be done, and to do it before China. Basically the same reason that they went there in the first place. So the progress made over the past 50 years has been essentially zero. And landing a couple of astronauts on the moon is well and good. It's very cool, but it's not really much more than a flex, a very costly and dangerous flex for all involved. During the Apollo program of the late 60s and early 70s, NASA managed to land 12 men on the moon. In the process, one crew of 3 men were killed in a pre-launch fire on Apollo 1, and 3 more very nearly lost their lives on the Apollo 13 mission. So that's not exactly a great track record, and definitely for the best that they stopped doing that before anyone else died in the process. All that to say, if NASA needs to do Artemis 3 just to show the world that they can still win in a pissing contest, then that's not ideal. But if we're going to make a meaningful return to the moon at some point in the not-so-distant future, then we are going to need to be in it for the long haul. If we're going, then we are going to stay. That's going to take a lot of hard work, and it's not going to be comfortable, but it will be the only way for humanity to gain a genuine foothold in our climb towards the stars. So let's talk about year 1 of humanity's first real mission to the moon. This is the space race. What are we going to find on the moon when we get there? Well, ideally, we would find a whole ton of very useful stuff awaiting our arrival. Several hundred tons of stuff to be more precise, and a small army of robots as well that have been hard at work getting things ready to the point that a human crew can hit the ground running and get our base operational. How big of a crew would that be? Well, we're definitely not just sending 2 people for this mission, but we don't want to send 100 either because a large group will require too many resources. There probably is a perfect number of individuals for a mission like this that can be determined by psychology and sociology. People get weird in isolation. We can look back at the biosphere experiments of the 90s, where they locked 8 people inside a giant glass enclosure for 2 years to see what would happen to them. Long story short, they went mad, and the whole thing is widely remembered as a disaster. Maybe something more like 10 or 20 people could pull it off if the right level of psychological screening was used. Infrastructure is going to be the key to a sustainable moon mission. The crew will be much less likely to reenact Lord of the Flies if they have a comfortable place to live. And if we're doing this, it's probably so we can kickstart extraterrestrial industry, and that means we are going to need plenty of tools and equipment to get that going. Like we said off the top, robots are going to be key to making this work. Even with our current technology, robots can do some pretty amazing things. Look at the Boston Dynamic Atlas, or even their little robot dog thing called Spot. Look at the Tesla Gigafactory, an ultra-modern manufacturing plant where machines build other machines. Give it just a couple more years and we will be comfortably at a point where robots can do nearly anything that humans can do, except they make those tasks easier, cheaper, safer, and in many cases they probably do the job better than a human would. Elon Musk has been promising that Tesla will build a fully autonomous humanoid worker bot by 2023, so we should be pretty well set for robots. Speaking of Elon Musk, the new SpaceX Starship rocket is going to be critical for establishing a human presence on the moon. Elon always stresses that the key to making life multiplanetary is the amount of mass to orbit. Elon says that to establish a self-sustaining city on Mars, we would need to move 1 million tons of stuff from the Earth to Mars. So getting set up on the moon is not going to require anywhere near that much because we don't need to be self-sustaining. We can always fly home if need be, and help is never far away. Each Starship Super Heavy rocket can lift 100 metric tons of cargo, so we'll need to buy a few rides from SpaceX, but probably not more than half a dozen. In theory, the best place to set up camp on the moon is going to be on the floor of a crater somewhere in the polar regions. The moon is covered in craters. Most are tiny, but a few of them are gigantic, as wide across as the state of Texas and several kilometers deep. And we know that in the bottom of that crater is going to be the remains of the asteroid that made it. The bigger the crater, the bigger the asteroid. And asteroids mean resources. We know now that most asteroids aren't just simple chunks of rock floating in space. These things are the building blocks of planets. They're full of all kinds of useful stuff, from water, oxygen, nitrogen, to iron, aluminum, and titanium. Our robots could scout out a crater location that is confirmed to have water ice in the bottom for us. Ideally, we want our base to be on the floor of a crater that is deep enough so that there is a permanent shadow and a consistent low temperature. Because trying to regulate the massive swings in temperature between day and night on the moon is not something that we are going to want to deal with. During the 2 weeks of sunlight, the surface temperature will rise to 106 degrees Celsius, meaning you could roast a chicken just by leaving it out on the ground. And during the 2 weeks of night, the temperature drops to negative 186 degrees Celsius. One really interesting thing about the moon is that it will never be completely dark because the Earth is always visible from the surface of the moon. It moves around in the sky but never sets over the horizon, and the Earth will appear brighter on the moon than the moon appears on the Earth, so the Earth is constantly reflecting light onto the moon. So we want the base of the crater deep enough to be in the shadow, but we also want the walls of the crater to come up high enough that they can catch a large amount of sunlight. There should even be craters near the moon's south pole where the bottom is perpetually in shadow and the high ridges along the walls are perpetually in sunlight. This would be ideal, because solar energy is going to play a large role in powering a moon base. One of the first construction projects we would likely take on as a crew would be setting up very tall towers with large mirrors on the top. Maybe some kind of a foldable mirror dish array like the one on the James Webb Space Telescope, where there are a bunch of hexagon tiles all fitted together. These mirrors would be very high above the colony and would reflect light from the sun down into our shadow base, and we could automate them to create an artificial cycle of day and night. Remember when we talked about people going mad in isolation? Living in perpetual darkness with a disrupted circadian rhythm is not going to help with that at all. So these sun towers would likely be worth the effort. Because there is no air on the moon, and therefore no wind, and only about 1/6 the gravity of Earth, it would actually be perfectly safe and stable to build very thin and very tall structures. And these can serve as double purpose as communications towers for creating a more reliable connection with the Earth. Since the distance between the Earth and the Moon is so incredibly small on the cosmic scale, only about 1 light second, an optical laser-based communication like the kind used by SpaceX Starlink satellites would allow for real-time communication between the two. At most, we would have a 2-second delay. Compare that to the same communications technology trying to reach from Earth to Mars. At the closest point, there would be 3 light minutes of delay, and at the farthest distance, there would be 22 light minutes between us. That's basically useless in an emergency. Speaking of safety, the crater would be a great first step to setting up a presence on the moon, but we would want to be actively scouting for safer locations. Craters exist on the moon because something big landed there, and there are no rules to prevent that from happening again. Large meteor strikes are rare, but the moon has no atmosphere to protect against micrometeors, so they would be a relatively constant threat. You can kind of think about meteors on the moon like lightning on the Earth. It doesn't happen all the time, but it does happen often, and it probably won't hit you, but it definitely could. So we want to explore alternative options with greater protections from the elements. We would want to engage in the first ever lunar spelunking mission into the depths of a lava tube. These are gigantic, naturally occurring tunnels that are underneath the surface of the moon. They would have formed by ancient volcano activity on the surface of the moon. Yes, volcanoes on the moon. That was a thing. We can confidently say that the moon has been volcanically active throughout much of its history. The eruptions probably date back as far as 4.2 billion years ago, and the peak of the volcanic activity on the moon probably occurred about 3 billion years ago. Some recent evidence even suggests that some small-scale volcanic activity was happening on the moon as little as 50 million years ago. So these tubes are created by flows of lava that channel under the surface. Once the flow of lava diminishes, it can essentially just drain out of the tube and leave behind a hollow void. We know that these tubes are present on the moon thanks to geological evidence called skylights. These are created when the ceiling of the tube collapses and leaves behind a round hole on the surface that reveals the hollow cave below. We've been able to spot a large number of these skylights through satellite imaging. So, what we're going to need to do is drop down through one of these skylights and find out what's going on below the surface. We're pretty sure that these tubes are going to be humongous on the inside, as much as 500 meters in diameter. The extremely low gravity on the moon makes it possible to have such a large hollow void that will not collapse. A large meteor strike on the roof of the cave would probably collapse it though, but the thickness of the ceiling can easily protect against small meteorites, as well as cosmic radiation and solar activity. It would be a much safer place to live than inside the crater. Staying fit and healthy while living on the moon is probably going to be a struggle. It's going to be exhausting, actually, because we are going to have to keep up super strict exercise routines that involve a lot of cardio and strength training because everything is lighter on the moon. Your body will naturally want to lose excess muscle mass and strength that it is not using anymore for day-to-day tasks. Low gravity environments can even lead to bone loss. We don't want that to happen, so we have to fight back with a lot of resistance training. Using big elastic bands or something like a Bowflex machine would be the only way to simulate an Earth level of resistance. Astronauts on the ISS have to work out 6 out of 7 days a week, and those workout sessions last for 2.5 hours, which is crazy. That's like an Arnold Schwarzenegger level of commitment to the gym. But that's what we're going to have to do on the moon. We'll need to constantly monitor ourselves for symptoms of radiation exposure because we really have no idea what effect that is going to have on the human body. Settlers on the moon would be far outside the Earth's magnetosphere, which is a magnetic field that extends out from the planet's core and acts like a reflective shield against cosmic radiation and solar radiation. It's one of the most important factors that keeps the Earth inhabitable. Without this protection, the surface of the moon will experience radiation levels that are at least 200 times stronger than the Earth, and maybe as much as 1,000 times more radiation at the peaks. Most of the radiation on the moon is coming from galactic cosmic rays. These are charged particles that are blasted through space at tremendous speed by the supernova explosion of dying stars. You would think that exposure to something like that would turn you into a superhero, but more than likely it would just give you some kind of space cancer. Anyway, we don't think that is enough of a problem to make living on the moon impossible. According to NASA's current radiation exposure guidelines for an astronaut's lifetime exposure limits, even the most at-risk astronaut could spend a total of 700 days on the moon. So we should be able to safely spend 1 year on the moon. We could maybe even do 2 years on the moon, but that would be the maximum risk that NASA would allow. So we wouldn't be able to go back to space ever again after those 2 years. Alright, so living on the moon is not going to be all glamorous and exciting all the time. Exploring never-before-seen underground caves is going to be a high point for sure, but there is a lot of just straight-up manual labor that is going to need to get done. Resource extraction is going to be critically important. We start on a small scale by exploiting the water ice in the bottom of our crater, but we need to ramp that up pretty quickly to start accumulating in situ resources. Even with the super heavy lift capability of the Starship, there is only so much that we can bring with us from the Earth. We can get oxygen on the moon by baking it out of the lunar regolith. That's actually going to be surprisingly easy. Most of the dust on the surface of the moon contains oxygen, and it also contains elements like silicon, aluminum, iron, and titanium. And the cool thing is that just by the process of refining these metals out of the regolith, we will create oxygen as a byproduct. So it's a win-win situation. We'd probably want to deploy large autonomous vehicles that would be kind of like combine harvesters. They would scrape the surface and collect the regolith and then bring it back to our base, where we would have a facility established to process and refine the material. Because there is such little gravity on the moon, all of this rock and dust is going to be extremely light, so we can move absolutely massive quantities of material without even the need for high-powered equipment. If we had something like a Tesla Cybertruck on the moon, which would be a perfect environment for such a ridiculous product, but that truck can pull at least 14,000 pounds on the Earth. On the moon, it could move the equivalent of 84,000 pounds. We would also be extracting resources by mining meteors. Remember that in the bottom of every single crater on the moon, there is going to be a space rock, and those can contain some wild combinations of elements. We've already been able to identify some extremely valuable asteroids in our solar system that contain metals like nickel, cobalt, platinum, or even gold. So we're likely to find all of those things at the bottom of some of these lunar craters. This is a big reason why we say that the moon is a foothold to industrializing space. If we're ever going to go into a future where we are manufacturing large objects in space, like vehicles on the scale of the Starship Enterprise, or massive space stations or O'Neill colonies, we can't do that by shipping resources up from the surface of the Earth. Not only is it unsustainable to mine that quantity of metal from the Earth's surface, it takes too much energy to get it through the atmosphere and into orbit. The amount of energy needed to transport something from the surface of the moon to low Earth orbit is going to be orders of magnitude lower than the energy required to move that same thing from the surface of the Earth to the same destination. Much longer distance, but much lower energy usage. The escape velocity of the moon is just about 2 kilometers per second. That's about 6 times the speed of sound. We could use a very long, high-speed rail track on the moon to gradually accelerate a train up to that Mach 6 speed, and then it would simply need to release the cargo and it would go flying straight out into space. As long as we have that aimed perfectly at the Earth, then the cargo should get caught by the gravitational pull of the planet and held in an orbit where it can be recovered by some kind of a tug ship that we would invent. Obviously, that whole launching stuff into space thing is going to take more than a year to set up. That's a long-term project, but that is the kind of thing that we would be laying the groundwork for in our first year on the moon. This is the kind of mission that is going to make going to the moon truly worthwhile. We have to go with a purpose and the commitment to tough it out for the long haul. How long until we can get to this point? I don't know. I feel like we're at least a decade away from even considering a project on the moon of this scale, and probably another decade after that before anything practical can actually get done. I'm just excited that we're going to have the opportunity to see a lot of this stuff in our lifetime. And that's really the best we can hope for. But please drop your theories in the comments section below. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.